In this episode, we're going to look at how to configure EtherChannel. I'll show you how to do it, and we'll talk about the concepts along the way. In our network, 3 switches have just been installed. There are redundant uplinks between the switches. As configured, only one of these links can be used. Otherwise, a bridging loop might occur. However, using only one link utilizes only half of the available bandwidth. EtherChannel allows up to 8 redundant links to be bundled together into one logical link. We're going to configure Port Aggregation Protocol, PAgP. Then we'll look at configuring Cisco EtherChannel Protocol. Then we'll look at configuring Link Aggregation Control Protocol. And then finally, we'll take a look at the IEEE 802.3 AD open standard version of EtherChannel. We'll be discussing how to configure basic switch settings, configure an EtherChannel with the Cisco's PAgP. Then we'll look at configuring an 802.3 AD LACP EtherChannel. And then finally, we're going to configure a redundant EtherChannel link. Greetings to all my tech heads out there in the KevTechify nation. And if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Configure EtherChannel. Here I have my packet tracer lab open. On the left side, I have our work area where we can see our configurations, our connections, where we'll do all of our work. On the right side, I have our packet tracer activity window that will give us our instructions for our lab. In this lab, what we're going to do is we're going to go through and configure EtherChannel using auto negotiation protocols. One is the Port Aggregation Protocol, PAgP. That's a Cisco proprietary. And then we're also going to configure using LACP, Link Aggregation Control Protocol. That's an IEEE open standard, so multiple people can do that. Looking here, what we're going to do here is in this port channel table, we can see that we have 3 different protocols here. Here's our PAgP, our LACP, and then our negotiated LACP. We're going to go through and configure them. Port channel group 1 goes from switch 1 to switch 3. So right here, switch 1 to switch 3, we're going to set up PAgP. Then our channel group 2 goes from switch 1 to switch 2. And that'll be LACP. So we're going to set up LACP right here. And then 3, we're going to go through and do a negotiated LACP right here. If we look at our diagram, I've had this up and running for a couple of minutes so that the ports could all get happy. And our spanning tree protocol is stopping loops from happening. If we look in here, we can see that there is no loop possible anywhere around. The amber circles right here, orange or amber circles, what they mean is these ports are in blocking states. So right here, both of these ports, they're in blocking, so we can't get all the way around. Plus, if you look at the connections between devices, so between switch 2 and switch 3 here, we have 2 connections where in theory, if we're just using the connections by themselves, it could come in on one and go out the other and create a loop. That's why one of these connections are set as a blocking port, so there is no loop here in between the devices, and the same thing here between switch 1 and switch 3. So we're going to create logical channels, and then we won't have any of those problems. On to our instructions. Part 1, assign each switch a host name according to the topology diagram. Okay, let's go in there and assign our switches. I'm going to go ahead and click on switch 1, come into our CLI. I always expand this out a little bit more. Type enable, get into privilege exec mode, config T, get into global configuration mode, and then our command to change host name is host name, and they want this to be S1. So I'm going to go ahead, minimize that, open up S2, light it up here, make it a little bit wider, click on my CLI tab, hit enter, enable, config, oops, gotta spell config T right. And then host name we want as S, 2, right? Yep. No, capital S. It's case sensitive, so make sure you get your capital S in there. There we go. I'm going to go ahead and minimize that window and go on to S3 quickly. Do the same thing. Make sure we're on our CLI tab. Hit enter, enable, config T, host name, and once again, capital S3. Okay, we've done part 1A. Part B. Before beginning the link aggregation between the switches, verify the existing configuration of the ports that connect the switches to ensure that the ports successfully join the EtherChannel. Commands that provide information about the state of the switch ports include show interfaces, include anything that has to do with internet, show interfaces static, and show trunk. Let's go ahead and take a look at those. I'm going to open up switch 1 again, exit out of global configuration mode. Now I can go ahead and do show interfaces space pipe sign space include capital E Ethernet, because once again this is case sensitive. I gotta spell Ethernet right. And we're looking, and we are connecting on switch 1. Fast Ethernet 20 and 21 and gig 0, 1, and 2. So fast Ethernet 20 and 21, they're both up and connected. Gigabit 0, 1, 0, 2, they're both up and connected. That's looking good. Oh, I'm going to open up switch 1 again. Type in that second show command. Show interfaces status. Once again, we are looking at 21 and 22. They're connected, they're auto, they're 10100, so they're fast Ethernet. And our gigs here, they're connected at 100 megs, auto negotiated, so that's all looking good. The third show command, show interfaces trunk. And there are no trunks. That's what we have for switch 1. Let's go ahead and take a look at switch 2. Exit to get into privilege exec mode. So it's show, oops, come on. Interfaces, space, pipe sign. Once again, that's the key above the enter key. You hold the shift key down, straight line up and down. So space, pipe sign, space, include capital E Ethernet. Oh, I spelled Ethernet wrong. On switch 2, we are looking at gig 01 and 02 and fast Ethernet 23 and 24. So fast Ethernet 23, 24 is up and up. Gigabit 01, 02, they are both up and up. That looks pretty good. Let's do our next show command. So show interface status. And once again, we need to spell interface correctly. And to fix that, all I did is hit the up arrow and then the left arrow that moves the cursor over. I corrected my spelling of interface and I just hit enter. So we are looking at, once again, fast Ethernet 23 and 24. They're auto, 10100. We're on the gig connections, auto, and 10100. So those are all, looks like they set like they're matching. And then show interfaces trunk. And there's no trunk set up. So that looks like no trunks are going to be set up here. Let's go ahead and check S3 quickly. Make sure that all those settings are correct. Exit out of global configuration mode into privilege exec mode. Show interfaces space pipe sign space include capital Ethernet. Once again, I cannot spell Ethernet right. And on switch 3, we are looking at fast Ethernet 21 and 22 and fast Ethernet 23 and 24. So right here we got 21 and 22 up, and 23 and 24 are up and up. Onto our second show command. So show interface status. We are looking at 21 and 22. Auto 10100. That's all looking good. That's what the other two switches look like. And we are looking at fast Ethernet 2324. Auto 10100. That's all looking great. And our last show command, show interfaces trunk. And we have no trunks. So all the settings are looking good. They're all set up. Let's go on to part C. Configure all ports that are required for the EtherChannel as static trunk ports. Okay, so what we're going to do is we're going to go in and configure them as trunks. Configure them as static trunks. What we have to do is go into those interfaces and then change that switch port mode to trunk. Let's go ahead and start on switch 1. So on switch 1 over here, fast Ethernet 21 and 22 and gig 21, 22 and then gigabit 0102. Okay, get into global configuration mode. Config T interface range, and then we can do a range of addresses. So fast Ethernet FA 0/21 space dash, or the minus sign, dash 22, and then you can put a comma in there, and then you can go gig 0/1 space minus sign space 2. That gives us a range of all four of those. Once again, it doesn't have to be contiguous, doesn't have to be right in numerical order. You can use two groups together. I did that. Now what we have to do is we have to do switch port mode, and then we're doing statically to trunk, and all we have to do is say trunk at this point in time. And then as you can see here, they went down. So fast Ethernet 21 went down, changed to trunk, came back up, and they went through all four ports that way. Okay, so that was switch 1. Let's go ahead and do switch 2. You can see here that these went up and down, received BGPUs on trunk, so we're going to have to sit down and start working on that. This is our spanning tree here, starting to work again. And our statuses went up. So let's go ahead, get into global configuration mode, interface range, and then we are on switch 2. So we have the gig interfaces and we have the fast Ethernet interfaces. So our range starts off with gig 0/1 space dash, or the minus sign, space 2, and then I'm going to put a comma, and then fast Ethernet 0, and we're on switch 2 here, so this is what we're looking at right here. 0/23 space dash space 24. And then switch port mode trunk. Go ahead, they go down, they'll come back up. They are looking pretty good. Let's go ahead and jump over to switch 3 right away. Get that done. And we can see here that we're starting to do blocking. So our STP is working because they're seeing the loops. They're not seeing the logical ports because we haven't created them yet. But they are seeing the separate physical connections, and we are starting to block this type. And we're also identifying inconsistent ports. One side's a trunk, one side's an access port. Okay, so let's go ahead, change that to a static trunk here. Config T, interface range, space, and then we are on switch 3. So we got 21, 22, and then we got 23 and 24. So we can do a range of 21 to 24. Fast Ethernet 0/21 space dash space 24. And we'll do all four of those. And then switch port mode trunk. There we go. Exit out. Exit out. We are done with part 1. On to part 2. We're going to configure an ether channel using PAgP. Once again, our PAgP connection here is going between switch 1 and switch 3. That's our port channel 1 right here. So we're going to configure this connection right here. If we notice, we have some blockings for the overall process, and we have this port being blocked right there. Hopefully we can create a logical port where spanning tree protocol won't block that then. Okay, down here to configure port channel 1. The first ether channel that is created for this activity aggregates port 21 and 22 between S1 and S3. Configure the ports on both switches as static trunks. Well, they had us do that up here. We went ahead and we did that. Now use the show interfaces trunk command to verify that we've done that. Let's go ahead and jump on switch 1. Exit out to privilege exec mode. Show interfaces trunk. And what we can see here is we're concerned with setting up 21 to 22. That's the one that goes to port or goes to switch 3. They are on, they have encapsulation, and they are trunking. These ports all belong to VLAN 1. They're allowing all the same ports through there. And we do have something happening with spanning tree right here. They're doing some blocking. Okay, that was switch 1. Let's go ahead and look at switch 3 quickly. Show interfaces trunk. Once again, we are concerned with fast Ethernet 21 and 22. Right here, we can see that they're both on. They have the same encapsulation, 802.1q, and they're trunking. We have the same VLANs being allowed across, 1 to 1005. Same VLAN here. And then we have some spanning tree information. That all looks good. And if we look at our instructions, that's the information we're looking for. On S1 and S3, add ports F1 and fast Ethernet 21 and 22 to port channel 1 with the channel group 1 mode desirable command. Mode desirable, active negotiation. Okay, so let's go ahead and do this. I'm going to go ahead and click on S1. Now, on S1, we're going to go ahead and enter in our commands. First thing is let's get into our actual physical ports. We can use that range command again. So interface range fast Ethernet 0/21 space dash 22 interface global configuration mode. Sorry. Now we can do interface range fast Ethernet 0/21 space dash space 22. So we have our range set up there. First thing you should do is shut them down, turn them off, because we're going to make a change to them fundamentally. We're going to bring them into a channel group. When you do a fundamental change like that, you should shut it down. So let's go ahead and shut it down. You got to spell shut down correctly. There we go. Now you can see that the statuses have all went down. Let's bring them into that channel group 1. So channel dash group 1. And then once again, our mode is desirable. We want to actively seek the auto negotiation of those. So channel group 1 mode desirable. So it creates the port channel, brings that information in there. I hit enter again to bring me to a new line, and then we'll turn them on. We'll activate that, and how we activate it is we do the no shutdown command. So no space shutdown. There we go, and now the states are coming up. That's S1. Let's go ahead and do S3. So S3 here. Get into global configuration mode. Interface space range space fast Ethernet 0/21-22. Shut it down first because we're making a fundamental change to it. You can see that it went down. Then let's go ahead and create our channel group. Well, what we're doing is not create, well, we're going to create it and then assign the ports in our range, our physical ports in our range, to that channel group. So channel dash group space 1. So it's our first channel group, and we're setting the mode to desirable. Creates it. We are good to go. We'll see that. We got our message looking good. On to D. Configure the logical interface to become a trunk by first entering the interface port channel number. So we're going to enter in that logical grouping. So anytime we do this logical grouping, it applies to all of them. And then we go and we say switch port mode trunk. Just like we're changing a physical interface, we can change that logical ether channel to that. Okay, let's go ahead and do switch 1 first. Switch 1. Exit out. So we are still in global configuration mode. So we want to go into interface, and then we're going into that logical port channel. So interface port dash channel space 1. That's the one we created above. Remember, we created port channel 1. We assigned those ports, or we assigned those physical interfaces to port channel 1. That's the one we're going to configure. First, I need to spell port correctly. There we go. Notice our prompt has changed. We are now configuring an interface. Even though this is a logical interface, our prompt still changes here. Once we're there, we can go ahead and assign it as a trunk. So switch port mode trunk. And spell trunk correctly. No, I forgot the word mode. Now, notice I'm having some typos. And what's happening here is, as a refresher here, first time I did something wrong, I spelled trunk wrong, it gave me a little caret sign underneath where the air is. So usually your air is somewhere there. I looked at the line, saw right where the caret is, and I could see I typed trunk wrong. So then I corrected it, I typed it in there. Now it says I have an incomplete command. Well, what I did is I forgot the word mode in between them. And so let's go ahead and correct that. So switch port mode trunk. There we go. Now we changed it to a trunk. Let's go ahead. I'm going to exit out quickly just to get in global configuration mode. I'm going to minimize this, open up switch 3, exit out to global configuration mode. Once again, we go into that logical interface. So interface port dash channel, and then it was port channel 1. Go ahead and enter switch port mode trunk. Looks like it's spelled correctly. There we go. And now we should be able to see our connections going up. Because they weren't trunks on both sides, it wasn't established. Our update packets get sent every 30 seconds. So if we watch here, I'm going to fast forward. Right here is the fast forwarding button. I'm going to go ahead and click fast forward. Looking at our topology, our red triangles that are pointing down, they should have turned green by now. And so I must have something wrong. Let's go ahead and see what's wrong. So I'm going to go into switch 1. I'm going to do a show space running dash config here from privilege exec mode. Go down, look at our interfaces. Our interfaces here, once again, we're looking at the fast Ethernet 21, 22. Those look good. Let's scroll up and look at our port channel. Those all look good. They're set as trunk. Go ahead and take a look at switch 3. I'm going to do a show run to see what our current configuration is, how we're configured there. Here's our port channel. Port channel 1 is switch port mode trunk. That's looking good. And then down to 21, 22, switch port mode trunk, group channel. Oh, 21 and 22 are shut down. For some reason, I didn't do a no shutdown. Oh, they must have went in air disabled mode. When we had the incompatibilities, they went into air disabled mode. What we need to do here is go in and disable fast Ethernet 21 and 22, and then re-enable it, and then hopefully here our connection should go up. So I'm going to keep it over here. Oh, config T, global configuration mode, interface, range, space, fast Ethernet 0 slash, and we were doing 21 space dash space 22, and we're going to do a no shutdown. They all went to up, exit out, exit out. Oh, I saw something flash here. They're flashing, they're thinking about it. Okay, while we're waiting for that, let's go ahead and do a show run again. Make sure they're good. Oh, the red downward triangles have now pointed to, or changed to orange. Still part of the negotiation process. I think we're doing good. Once again, that negotiation process will take up to about 30 seconds. And there we go. And notice we have all greens all the way around. We have greens because this is one logical grouping now. STP sees it as one connection. And so there isn't a little loop here between the switches. It's just one logical connection. Spanning tree will not shut that down. Of course, now that we did this, they went through the election process and stuff like that. And notice that we have the block ports down over here. They were up over here before. Now they're down here. But this is up and running. It's looking good. Okay, so we're going to verify the port status of channel 1. Let's go back to switch 1 here. And do the show space EtherChannel summary command. Here we have our EtherChannel 1. Port channel 1, we have an S and a U. Once again, here's our S saying it's a layer 2. We have a U saying it's in use, so that is good. Fast Ethernet 21 is a P, which is, it's in a port channel. So is port 22, so that is all looking good. That's exactly what we want to see. Okay, so if it doesn't come up, we can use the show interfaces trunk and show spanning tree commands to see what was going on. I use the show running command. That's usually my go-to right away. But if that wouldn't have worked, I would have then defaulted to the show interfaces trunk and then the show spanning tree. So that looks pretty good. We got that up and going. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Now what we're going to do is configure an 802.3 AD LACP Ether channel. Once again, this Ether channel is over here. We're going to go between S1 and S2. We're going to create that LACP auto negotiation Ether channel. Okay, so step 1, configure port channel 2. We're going to configure port channel 2 over here. We're going to use the IEEE 802.3 AD, which is an open standard Ether channel. We're going to configure the link between S1 and S2 using the gig 01 and 02 on each of these devices. Use a different port channel on S1 than 1, because remember, this is port channel 1 over here going between S1 and S3. Over here for port channel 2, or sorry, over here for this other connection, port channel 1 is already used on S1, so we can't use that. So we have to use a different one. We just go to the next number. So we're on port channel 2. And then we have to remember that it is mode active, not desirable. Desirable was PAgP. LACP is active. They do the same thing. Okay, so let's jump in here. S1. We're here on S1. Get into global configuration mode, config T. Then we got to get into our gig 1 and 2 interfaces. So interface range gig 01 space dash space 2. We have our range there. Go ahead and we shut her down because we're doing a fundamental change to it. Got to spell shutdown correctly. You can see our shutdown went. And then to create this, we start off with channel group, channel-group. We are using number 2 again. And it is mode. And if you don't remember what it is, you can put the $sign in there, space $sign. And then these are all the ones that are available. We are using LACP. And we are using the active. So mode active. There we go. Now let's go into the interface of the actual port channel itself, that logical channel we just did. Oh, hang on. Before we do that, we have to turn those physical ports back on or activate them by doing a no shutdown. There we go. We can see they went up. Okay, now we can go into that logical port channel 2. So interface port dash channel space 2. Now into the logical interface, and then we need to say URA trunk. So switch port mode trunk. There we go. We have that side configured. Now we have to go and do the other switch. Up here it says switch 1. Now let's go ahead and do switch 2. They gave us the configuration for switch 1. Now we got to do it on switch 2. Okay, switch 2. Enable config T global configuration mode. We want to do our range of physical interfaces. So interface range, and we were doing gigabits. So gig 0/1 space -2 gives us our range there. Once we're in our range, we start with channel group 2 because we want to pull all those physical interfaces in our range here into a channel group number 2 so it matches the other side, and then mode, and we are doing active for LACP. You see that we have a bunch of our channels going up. Once again, we're still in the range of the physical interfaces. While we're there, let's do a no shutdown because we shut it down. We brought them into a port channel. Now we're bringing it up. Now let's go into that actual interface of that logical port channel. So interface port dash channel 2, and then from here let's go ahead and do switch port mode trunk. Let's go ahead and use some show commands to verify everything is working correctly. Let's jump back on switch 1. Exit out, get into global configuration mode, exit out one more time so we're in privilege exec mode. Show EtherChannel summary. And here's both of our Ether channels. Once again, EtherChannel port group 1 is going to switch 3. Group 2 here is the one we just created. So port channel 2 has an S and a U. S is it's a layer 2, U is it's in use, so that's all good. And gig 01 and 02, they are P, so they are ports in use. Everything is looking good for our Ether channel. Go ahead and minimize that, and you can see everything is up and running this time. We have all of these, we have all of our connections. STP is not blocking anything here. STP is still blocking here between S2 and S3 because these are physical ports. There is a loop here. On to part 4, configure a redundant Ethernet link. So what we're going to do is here, we're going to configure port channel Ethernet 3. Once again, that was between the 2 bottom switches. Switch 2 and switch 3 is what we're going to look at. There are various options for the channel group. So they want us to get in here. What we want here is EtherChannel 2. And so yeah, we're working on this connection right here. So let's get into switch 2. I started on one side of it, so let's get into there. Get into privilege exec mode. Got to type exit a couple of times. Actually, we needed to stay in global configuration mode. Let's go into our interface. interface range. And then we're doing a fast Ethernet 0/23 space -24. Here's our range. Start off with channel group 3. We've used channel group 1. We use channel group 2, so we're on the 3 right now. So we're on channel dash group space 3 mode, and then let's put a question mark in there and see. Once again, these are all the different choices we have. And what we're looking to do is use LACP on this side. So we can either do active, which is unconditional, or we can do passive, only if another LACP device is detected. So those are our choices. Now on switch 2, what we want to do is take our 2 ports, fast Ethernet 23 and 24, and turn them into a passive. Turn them into creating a link only if the other side is negotiating the connection. And so we want channel group 3 mode and then passive at this point. Once again, we got to spell passive correctly. We take it down, make the change, they bring back up. That's pretty good. As long as, once again, we are in the physical interfaces here. We shut them down. We made the change. Now we have to bring them back up. We have to activate them. We do that with the no shutdown command. They come back on. And now let's go into that logical interface. So interface channel dash, sorry, not channel. This is port channel. So port dash channel 3. And we want to change that to a trunk mode. So it's switch port mode trunk. And now we've created it as a trunk. Now we need to go on to switch 3. Here on switch 3, we want to turn it into the active mode. The LACP mode that's saying, hey, let's create a connection. Let's go ahead. Let's do that. Okay, go ahead and log in. Luckily, we don't have some passwords here. So enable, get into privilege exec mode. Now we get into global configuration mode, config T. Our interfaces were fast Ethernet 23 and 24. So interface range FA 0/23 space -24 gives us a range of 23 to 24. Let's shut that baby down. Once again, spell shut down correctly. Once it's shut down, let's go ahead and create that channel 3. That's the one we're creating between the 2 switches. In the mode we wanted to set this one to here is active. Okay, I need to go back, make a typo change. So mode and then active. We created it. We set it as active. We're still in those physical interfaces. We shut them down. Now we need to turn them back on. So let's go ahead and do a no shutdown. Now they're back up. Port channel 3 even changed to up. So that's looking good. Let's go into that physical interface of port channel 3. So interface port dash channel 3. Here, let's turn that into a trunk also. So switch port mode trunk. We have that. Exit out. Verify this, use the show commands. Show EtherChannel summary. Oh, wrong mode. Exit. Show EtherChannel summary. And get rid of the and. That command shows us our port channels. Here's the channel, port channel 3 we just created. Once again, we have the S and the U. S is for layer 2, U is for in use. That all looks good for port channel 3. And our two physical interfaces, Fast Ethernet 23 and 24, they have a P, which stands they are in a port channel. Next up here is creating the EtherChannel link does not prevent spanning tree from detecting the link. View the status. Okay, what I'm going to do is I'm going to minimize this right here. Look at our diagram. Now, each one of these double connections between the switches, they're no longer a trunk because that's a logical connection, but we have a logical connection between each switch, between switch 1 and switch 2, switch 2 and switch 3, and switch 3 back to switch 1. So that's a loop in itself, and spanning tree blocked both of those physical connections, that one logical connection, so we don't have a loop. Spanning tree is working correctly. So if one of these connections goes down, one of these, okay, it gets a little complicated. If one of these connections goes down, the other one still stays up because it's part of the port channel. But if that entire port channel goes down, then spanning tree will recover and it'll activate these two connections here. Okay, so on S1, let's do a show spanning dash tree active. Spanning tree is active. What we can see here is port channel 1 is forwarding, but port channel 2 is blocking. And that's what we can see from this diagram right here, is port channel 2 right here is blocking. And so it's not the individual ports that's blocking, it's that logical connection, because that's what we have is we have these port channels, these ether channels between devices, and spanning tree blocks the logical channel, which essentially blocks all the physical channels. So it's blocking the port channel interfaces. That's what we're seeing right here. Port channel 2 is not operative. In this topology, you can restore these ports by configuring S1 to be the primary route for VLAN 1. You could also set the priority to 24,567, which is less than the default. Remember, the default was 32,000. Here it's 24,000, and the lower number wins, so you can set that. And so either two ways you can do it. You can either say set root primary, or you can set the priority to that. I'm going to go ahead and do the first one right here. So we get into global configuration mode, config T, and then spanning dash tree, I spelled tree correctly, VLAN 1, because that's what we're looking at here is VLAN 1. We're going to say is the root primary. Exit out. And now we may have to wait for STP to recalculate here. But as you can see, it's doing some recalculations already. It's thinking about it. These are blocking, and everything. So we can't get data around here. We don't have full connectivity, but these are sort of flashing. I don't know if you can see it on your screen, but they were flashing green almost. They're thinking STP is doing some recalculation, and now they turn green. And so because we set this as the main root up here, we're seeing that these are all active, and then it went through the recalculation process and decided we're going to block these. These are root ports here. These are the ones that are listening, receiving the information, and if they're both receiving, these are roots here, the other connections have to be receiving, because this is sending data, this is receiving our BPDUs. One of these have to be blocking, and because of how the election process worked, it is this one. Must be a lower MAC address at this point. EtherChannel configuration guidelines and restrictions. Here are all the different restrictions. All Ethernet interfaces support EtherChannel up to a maximum of 8 physical interfaces. So up to 8 physical interfaces you can have. No requirement that the interfaces must be on the same module or even contiguous. They don't have to be 1, 2, 3, 4, 5, 6, 7, 8. They can be 1, 2, 3, 8, 7, all the way until you get up to 8 ports. All interfaces within the Ether channel must operate at the same speed and same duplex. So either 10 megs, 100 megs, gigabit, 10 gigs, they all have to be the same, and they either have to be all full duplex or all half duplex. Ether channel links can function as either a single VLAN access port, so you can take that logical Ether channel and say, hey, you're in access mode and only one VLAN worth of information can go across. Or we can set that Ether channel, that logical Ether channel, up as a trunk, and that trunk would handle all VLANs worth of information. All VLANs in layer 2 Ether channel must be members of the same VLAN. Now, if you have your physical ports as access ports and they're in VLANs, they all have to be in the same VLAN. All those physical Ethernet ports have to be in the same VLAN. If configured as a trunk, layer 2 Ether channel must have the same native VLAN and have the same VLANs allowed. So when you set it up as a trunk, those trunk ports, you have to have the same native VLAN. If you change away from the default native VLAN of 1, you need to make sure all of your ports are in the same native VLAN on the switch and on the FAR connection. All of those ports. Also, you have to allow the same amount of same VLANs across. When configuring Ether channel links, all interfaces should be shut down prior to beginning the Ether channel configuration. When it's done, you should turn it on because you're doing a major change. Now, some of you may have caught it in the lab. I didn't shut down once. You can usually get away with it, but sometimes it does cause problems. And especially in a production environment where you're working on production equipment, I would always shut it down. Make your change, bring the physical ports into that logical, and then turn those physical ports back on. After configuring Ether channel, verify all interfaces are in the up state. It's always good to do a show interfaces, show running, use one of our show commands to make sure that they all are up and running. Now, when we're doing this negotiation for Ether channel, there's several commands here, or there's several modes you can have. LACP has 2. It's either active or you can have passive. Active, what they say is here is enabled unconditionally. This is the interface that's saying, hey, I want to make an LACP Ether channel. Yes, I do. Will you join with me? And so they're actively looking for that. Passive is the one that's sitting back sort of going, if you want to make, or I want to make an Ether channel with you. I want to make an LACP Ether channel with you, but hey, I'm not going to start that conversation. If you want to start it, I'll do it, but otherwise this just ain't going to happen. PAgP has desirable and auto, and they're basically the same thing as LACP. Desirable is that one that's out there looking to make that connection. Hey, let's make that connection. Let's do it. Auto is the one that's sitting back saying, hey, I'll make that Ether channel with you, but you have to start the conversation. The other option for both LACP and PAgP is on. And regardless of what negotiations it is, it's just on. It doesn't do any negotiation at all. Now, the LAN ports, they have to be compatible with each other. You can do a desirable to desirable. That'll work because they're both looking to make that connection. You can do a desirable to with an auto, because one is saying, hey, let's make that connection, and the other one is saying, if you start that conversation, I will do it. And so you got one that's eager, one that's willing, and so you get them together, those will work. But if they're both in auto, they're both sitting back there and saying, hey, I'll make that Ether channel, but you need to start that conversation. The other side said the same thing, so none of them starting that conversation. Same thing here with LACP. It's the same concept. Active to active, they're both actively looking for it. Active to passive, one is saying, hey, let's make it. The other one's saying, only if you start the conversation. If both are in passive, both sides are saying, we'll do it, but you have to start the conversation. And so they don't start that. EtherChannel group numbers are local to the individual switch. In our lab, we kept them the same. But realistically, if it's not used on a switch, but it's used somewhere else in your network, you could use the same numbers. I sometimes find it's helpful not to reuse them, but if you do have a lot of ether channels in your, or channel groups in your network, you're going to have to redo those or reuse those numbers. That was Packet Tracer Lab 6.2.4 Configure EtherChannel. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.